Welcome to Ask and Learn.
Hello students, we are given that the resistance is proportional to the velocity. So dv by dt is equal to minus kv. We need to find the value of k. We know that the velocity decreases from 40 feet to 20 feet per second in 10 seconds. So we can write the equation as dv by dt is equal to minus k into multiplied by v. Now we can solve this differential equation by separating the variables. So dv by v is equal to minus k into dt. Now integrating both sides, we have integration dv by d is equal to integration minus k into dt plus c, where c is the constant. So this implies ln v is equal to minus kt plus c. This implies v is equal to e to the power minus kt plus c, where c is the constant of integration. We can write it as e to the power minus kt into e to the power c, that is a equal to e to the power minus kt. So v equal to a into e to the power minus kt. A is the constant. Now you use the initial condition. So t equal to 0 and v equal to 40 feet per second. So we have a equal to 40, and the second initial condition is at t equal to 10 and v equal to 20 feet per second. 20 is equal to 40 into e to the power minus 10k. This implies e to the power minus 10k is equal to half. So k is equal to minus 1 by 10 into log of half, that is equal to 0.0693. So v is equal to 40 into e to the power minus 0.0693. To find the distance, we need to integrate the velocity function with respect to time t. So integration v dt is equal to integration 40 into e to the power minus 0.0693 to dt. So this implies s of t is equal to minus 40 by 0.0693 into e to the power minus 0.0693 plus c, where c is the constant of integration. Can express it as c dash. So if we use the initial condition, that is at t equal to 0, s of t equal to 0, so c dash is equal to 40 by 0.0693, and which is equal to 577.2006. So the equation for distance is s of t is equal to minus 577.2 to e to the power minus 0.0693 t p, that is equal to s of t is equal to minus 40 by 0.0693, that is 577.2 into e to the power minus 0.0693 plus 577.2. To find the total distance the boat will coast, we need to find the time when the velocity becomes 0. So s of t equal to 0. This implies e to the power minus 0.0693 t is equal to 0. This equation has no solution. This equation has no solution. So the means that the boat will never come to a complete stop. However, we can find the distance it will coast at the time approaches to infinity. So limit t tends to infinity, s of t is equal to s of infinity equal to 40 by 0.0693, that is equal to 577.2, which is the required answer. Hope the video is useful to you. Thank you.